Now we know how to write ionic compound formulas, let's talk about how to name ionic compounds. So remember, the first thing you ask yourself is you determine if it's ionic, and you can do so by asking yourself, does it contain a metal and a non-metal? Okay. Once you have done that, you ask yourself, is it type 1? Is it a type 1 ionic compound, or is it a type 2 ionic compound? And to answer that question, you need to find out or take a look at the periodic table and determine if the metal can form more than one type of ion, which is type 1, or if it can form more than one type of ion, which is type 2. And the metals that can form more than one type of ion are the metals in group 1A, 2A, 3A, zinc, and silver. Okay? The type 2 metals are everything else. Okay? All of the other metals. The ones not in group 1A, 2A, 3A, zinc, and silver. Okay? So, if it is a type 1 ionic compound, it is very simple to name those compounds. You just name the cation, which is the metal name, and then you name the anion, which is the non-metal name, with the ending changed to end in "ide." So, for example, NaCl, you name the cation, sodium, you name the anion, chlorine, and you change the ending of the anion to end in "ide," so it's chloride. So that is simply sodium chloride. Okay, let's take a look at Rb3. N. To name it, we name the cation, which is rubidium. I don't expect you to know that, by the way. We name the nonmetal, which is nitrogen, and we change the ending of the nonmetal to end in "ide." Rubidium nitride. Okay, let's do one more. MgF2. We name the cation, magnesium. We name the anion, which is fluorine, with the ending changed to end in "ide," fluoride. Okay, so simply name the metal, name the non-metal, change the ending to end in "ide." Okay, if your compound contains polyatomic ions, we do not change the ending. We just name the polyatomic ion. For example, sodium nitrate, calcium phosphate, magnesium sulfate. You just name the polyatomic ion. Okay, notice we did not use any prefixes. This is not magnesium difluoride. Okay, this is not trirubidium. It's just magnesium fluoride, rubidium nitride. Okay, so what if your metal is a type 2? A type 2 metal can form more than one kind of ion. Well, when we're naming those, we need to name the cation. We need to write parentheses with Roman numerals showing the charge on the cation, and then we name the anion again with the ending changed to end in "ide." So the big difference between type 1 and type 2 is we include the size of the charge on the cation in Roman numerals in parentheses in the name. And the reason we do that is if the metal can form more than one type of ion, it's important that we know which charge we're talking about. Are we talking about copper 1+ or copper 2+, iron 2+ or iron 3+, tin 2+ or tin 4+? Okay, so we let the reader know that information by including that charge as Roman numerals in parentheses after the cation name. Now, we do not include the positive sign in the parentheses. We just say, for example, iron 2 or lead 4. We don't say iron 2+, lead 4+, because the plus is implied, right? It's a metal, so we know it's positive. So, for example, say we want to name PbCl4. Pb is lead. It's not in group 1A, 2A, 3A, and it's not zinc or silver, so it must be type 2, which means it can form more than one type of ion. So we're going to name it lead, and then something in parentheses, chloride. Okay, so how do we work out the something? Well, we work out the charge on the lead by looking at the anion. Okay, so our anion is chlorine, which is a 1- ion, and we have 4 of them. Okay, so we've got 4 chlorines. They're all 1-, so our total negative charge is 4-. That means our total positive charge must be 4+, because they have to be equal. We have 1 lead in the formula, so that entire 4+ charge must be on that 1 lead, right? So that means that the charge on the lead is 4, and so the number that we put in here in Roman numerals is 4. So it's lead 4 chloride, which means that the charge on the lead, this number right here, is 4. Okay, this number in Roman numerals is not the subscript on the lead, it is the charge on the lead. Let's look at some others. Let's do some more examples. For example, let's do Fe2O3. Okay, now I strongly suggest you set it up the way I'm doing it. So it's kind of a backwards horseshoe, okay, kind of a U shape like this. So start off with your cations, sorry, your anions. There are 3 anions, 3 oxygens, and they're all 2- because they're in group 6A. This charge doesn't change, okay, it's always going to be 2-. There's 3 of them, so that's 6-. That means the positive charge is 6+. There are 2 ions in the formula. So the 6+ has to be shared evenly between those 2 ions. So they get 3+ each. Okay? Because it takes 2 times 3+ to get 6+, and 3 times 2- to get 6-. Okay? So that means this compound is called iron 3 oxide, because the charge on the ion is 3+. Okay, let's do one more. Cu2O. Cu is copper. Again, set it up the way I showed you, like a backwards horseshoe. We've got 1 oxygen, it's 2-. That means our positive charge must be 2+. There are 2 coppers in the formula. So we share that 2+ evenly between the 2 coppers, and they get 1+ each. So that means that the name of this compound is copper 1 oxide, because the charge on the copper is 1+. Remember, in chemistry, usually the 1 is implied. We don't write a subscript 1, but in this particular case, when you have a type 2 ionic compound, you must include the 1 in the name. Otherwise, the reader won't know which copper you're talking about.